Question 7, we are told that the weight of bags of rice is distributed normally. So I was very surprised at the lack of diagrams for this question. Please, whenever you're dealing with a normal distribution, draw a sketch and you can see what you're dealing with. In fact, you actually got marks. Sketching counts as a method mark. So if you sketched the normal distribution and labelled it correctly for each question, you would have got 1 mark at least, and then 1 mark for the right answer. So a bell curve, normal distribution looks like this. The mean being 50%, so the mean being 1,000, and then standard deviations going up and below. We usually count up to 3 standard deviations away because 99.7% of the population will fall within 3 standard deviations below or above the mean. So 1 standard deviation above would be 1,004, and then another standard deviation 1,008, and another standard deviation 1,012, and then below 996, 992, 988. Okay, so find the probability that the bag of rice is chosen is between 990 and 1004. So if we drew our sketch again, there's the middle, 1004, well that was our 1 standard deviation above, but 990 is between 2 and 3 standard deviations below, so we want this part down here. So we want the probability, if I choose one of these bags of rice at random, that its weight will be between these 2 things. So this is a normal CDF calculation, a normal CDF, we always use CDF, not PDF, with a lower bound of 990, an upper bound of 1004, and then the mean and standard deviation as given in the question. So you would do that, menu, statistics, stats, distributions, as a normal CDF. So your lower bound was 990, upper bound 1004, mu is the mean, so that was 1,000, and the standard deviation was 4. Okay, where did it go? Let's try that again. Distributions, normal CDF, 900, 1,004, 1,000, and 4. Okay, there we go, fantastic. So that's 0.8413, etc. So to 3 significance, 0.841. 0.841. It's okay to leave it as a decimal. In fact, I would advise you to leave it as a decimal. Some of you put it into a percentage, so 84.1%, that's fine. But the reason the sketch is helpful is because I can tell that I'm looking for quite a big number, because look how much of my diagram is shaded in. Okay. In the next part, we're told 95% of the bags weigh less than k grams. So if this is my normal distribution again, there's 1,000 there. There's some cut-off point k somewhere up here, where below we've got 95% of the bags of rice. So the calculator, when it's dealing with area, always works in decimals. So you want 0.95 out of 1. So this, when you're given the area and you're trying to find the value, this is an inverse normal distribution. It's the other way around to what we were doing before. Before we had the values, the cutoff points, we wanted the area. Now we've got the area and we want the cutoff point. So it's inverse normal. So same place as before, menu, stats, distributions, inverse normal. And it's saying what area do you want? The calculator always goes from left to right. So we want 0.95 to be less than this value k. The mean is the same and the standard deviation is the same. So the cutoff point k, it says, is going to be at 1006.5794. Let's make a note of that. So this k is equal to 1006.9714. I think that's what I said. Okay. To 3 significant figures, this one's a funny one because it would be 1,000 and then the 6 would round this one up. So it'd actually be 1,010, which seems like quite a way off. So you got marks if you put 1,010 as well. Okay. This one was where a lot of people were tripped up. So again, I'd always advise you to draw a sketch. Okay, this is 1,000. A bag of rice is chosen at random. Find the probability that find the probability P that the bag weighs in between 1,000 minus A, so somewhere down here, minus A, and 1,000 plus A, somewhere up here, 1,000 plus A. So we want to find this value of A, and we want 90% of the rice to be between these two cutoff points. So here we've got we want this to be 90%. Well, 0.9. So it looks like I'm going to be dealing with, well, I am going to be dealing with the inverse normal. But the thing is, like I said before, the calculator is just going from left to right. So for example, if I wanted to find this value here, like this, I'd have to tell the calculator the percentage all the way up to that point, not just this middle part here. So think about the normal distribution. It's meant to represent the whole of the population. It's meant to represent a total of 1 or 100%. So if I've got 0.9 or 90% represented here between these two values, then what percentage of the population have I got on either end? Well, in total, I'd have to have 10% left over, or 0.1. And we know that the normal distribution is symmetrical. So if I want to have 0.1 outside of this area, then I need to have 0.05 at this end, and I need to have 0.05 at this end, because it's got to be symmetrical. So that was the key point, really. You had to think about how the whole population was distributed either side of the 0.9. So if we come back to this question down here, the calculator only goes from left to right. I want to find 1,000 plus A, somewhere up here. What percentage of the bags of rice fall below this point? Well, it's 0.9 for the middle part and 0.05 here. So on the calculator, I'm actually looking for 0.95. So I could do inverse normal, 0.95. Now, in fact, some of you would have noticed that's exactly the question that we did before. Look, inverse normal, 0.95, mean and standard deviation, and the answer was 1,006.5794. So that means that this here, or in other words, 1,000 plus A is equal to 1,006.9714. And we want to find A. So if 1,000 plus A equals that, then A is equal to this number minus 1,000, which would just be 6.9714. And to three significant figures, 6.98. Okay, so the key part there, when you're dealing with a normal distribution, draw yourself a sketch. You would have got a mark for drawing this out, and just think, if I've got 0.9 there, then I must need 0.1 in the other areas, and because it's symmetrical, I half the 0.1 at the top and half the 0.1 at the bottom.